Welcome back to the Scotti-BYTE channel, and this is Scott. So 2 videos ago, I made a tutorial entitled It's Always DNS in Containers. And before that, I've made a couple of videos where I've discussed DHCP and how it works. So one of the important things that you have in your home lab is having an understanding of how addresses get granted through DHCP and how they get specifically accessed. And so this video is not really about DHCP, but it is a little bit about how we access different addresses for systems on our network. So I entitled this one, List My Subnet. So most home labs have a default LAN address range of 192.168.1.0 with the subnet mask of 24. And the subnet mask of 24 basically means that your address range allows the last octet, the 0 you see there, to change all the way up to 255. And there's generally some reserved addresses, like the 1 address is usually your default gateway, and the 255 address is normally your broadcast address. So IPv4 is broadcast based. And what exactly does that mean? Well, Address Resolution Protocol, otherwise known as ARP, works by sending an ARP request to an IP address on your LAN to find out what a particular MAC address is. And so this media access control, or MAC addresses, are unique identifiers assigned to a network interface card, otherwise known as your NIC, for communications at the data link layer 2 of the OSI model. And so if you did something like an if config, and you see that you've got an address like I mentioned here of 52:54:00 and so on, that is referred to as the MAC address or the hardware address. And so that hardware address has actually become somewhat of a misnomer nowadays, because we actually have a lot of virtual devices that now have MAC addresses. And the advantage of a MAC address is to provide uniqueness for a device on the network, but realize that your TCP/IP address is just a more convenient way to refer to a unique hardware device on your network. Just realize that that hardware device can now be a virtual device. So devices communicate using IP addresses, but the data link layer needs MAC addresses to deliver packets on your local area network. And so your system checks to see if it already knows the MAC address associated with an IP address. So if you tell it, hey, I want to go talk to 172.16.1.10, it'll go ahead and look up in its ARP table whether or not it has a cached value for the MAC address for that particular IP address. So with that in mind, let's go take a look at how we use the MAC addresses and how ARP works on your local area network. When your computer attempts to communicate with another system on your local area network, it will look in your ARP table to find out if it has a MAC address translation for the TCP/IP address that it's trying to reach. And if it does not, it will go ahead and send out an ARP broadcast to discover the MAC address of the system associated with that TCP/IP address. So there are 2 ways that you can look at your ARP table on your local machine. One way is with the command IP space NI, otherwise known as IP neighbors, and that will go ahead and give you a listing. And as you can see here, I have a huge number of systems, and some of them are going to be TCP/IP version 4, and I also have TCP/IP version 6, although those are all local link layer addresses, and IPv6 is another subject. So we're not going to look at that specifically here. Besides the ipni command or IP neighbors command, you can also use the command arp-a, and it will go ahead and make the same listing here, although in this particular case, we're looking at really all IPv4 addresses, and so arp-a is typically the command that I will use. Sometimes you might be having communication problems on your network, and one of the ways that you can solve that is you can clear the ARP table knowing that it will be automatically rebuilt. So this command, sudo IP space -s space -s ni flush all, says flush all the neighbors from the ARP cache. And it says deleting 97 entries, and flush is complete. Now if I go back up and do an arp-a, I have a relatively small ARP table because it's already been reaching out to other systems. And here in these entries, you can see it has an IP address, it has a DNS entry if I have a DNS entry for the system it tried to contact, and then it has the hardware MAC address, which is the entire point of having an ARP table. And then it has which interface it contacted that system over, and on my desktop system, bridge 0 is my default route. There's a way to watch the ARP table being built real time, and to do so, we can use the command TCP dump. If you don't have TCP dump installed on your system, you can install it with the command sudo apt install TCP dump. So the command we can use to be able to look at that is this command here, which I'll put in the show notes. And basically what I'm doing here is I'm finding out the default route. The way that I do that is I try to go to Cloudflare, which is at 1.1.1.1, and by doing so, I can determine which interface that goes through, and I do a TCP dump using that interface. And now you can see here, it's listening to the ARP broadcast live on my local area network. And to get out of that, I can simply do a Control-Z. Close to a year ago, I did a tutorial that was entitled Home Lab Network Monitoring, where we installed NetAlertX. And NetAlertX is a great tool to track what is running on your network and to send out notifications when something goes down or something is discovered new on your network. So there's a basic way to do that, and to do so, I kind of developed a little bit of a script here, and I'm going to call that script scan_subnet.sh. And so basically it's a bash script, and it goes out and determines what your default network is, and it goes ahead and scans that. I'm going to go ahead and put this in the show notes. So let's see how we can use scan_subnet.sh. Anytime you create a new bash script, one of the important things you're going to do after you save the file is you have to grant that bash script execute privilege, or else it won't run. And so I do a chmod +X, which means add the execute privilege to scan_subnet.sh. And then if I do an ls-a on scan_subnet.sh, you'll see that it, let's see, we want to do an ls-al, I guess, and it will go ahead and call out the fact that I have execute privilege here for the owner, and for others, or the group, and then also for others. So that allows people to execute that particular script. So now, in order to run the script, we're going to execute the command /scan _subnet.sh, and then out here you're going to put the subnet along with the subnet mask. So in my particular case, I'm going to scan 172.16.1.0 with a 24-bit subnet mask, which means it's going to discover anything that's on my network at 172.16.1.anything. So in your particular case, if you're using the default network on your router, it's probably something like 192.168.1.0/24. So when I run this program, it'll go ahead and scan my subnet, and then it will go ahead and print out a listing of everything on that subnet. First of all, column 1 has a host name, and it's assuming you have local DNS. And lately, I've done quite a bit about local DNS and using Pi-hole for local DNS on your network. The second column is the TCP/IP address, and the third column is the MAC address. So again, just as kind of a recap, if you go out and use DHCP to grant an address to a container or a computer on your network, it is storing this hardware MAC address for that device. So anytime that device comes back up on your network, it generally grants the same TCP/IP address if you have a DHCP address reservation set for it, or if you have a static address set for it. So it recognizes the uniqueness of a system, not based on the name of the system, but based on this hardware MAC address that you see here. So as an example, with this listing, I have something that's been discovered at 172.16.1.250, and it says unknown because I don't have a DNS name for it, and that might be an indication that I want to go out to my Pi-hole and add a DNS entry for it if that's one of the systems that I want to be recognized by name. Something else I'm going to go ahead and put into the show notes is the fact that this script also requires the installation of a program called Nmap, which is Network Mapper, and it is used to discover the TCP/IP addresses and the ports available at those addresses optionally for services offered out on your network. So the fact that we have run this script, and the script uses Nmap, and it is basically probed the network, also means at this point, if I do an ARP-A again, we're going to have many more entries in our ARP table. And in fact, if we scroll all the way up here, you can see that there are a huge number of entries here as it's discovered the various services on this main network of 172.16.1. So in summary, the ARP table contains the mapping between IP addresses and MAC addresses on your local area network. And the ARP table is built by listening to ARP broadcasts. Systems use IP addresses and map them to the hardware MAC addresses to communicate on the data link layer of the OSI model. And don't be afraid to clear your ARP table on a system where you have communication problems, and you can do that with the Linux command sudo IP-s --s ni flush all, because sometimes it's just ni time to clear your ARP table. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.